So here in 5.4b, we're going to finish up our factoring stuff. We looked at the hardest one yesterday, so we really are just kind of finishing up here today. But like I said in the 5.4a, factoring is one of the most important things that we do. Now, we looked at the ones in 5.4a, these right here, where they are, they're just tricky. I don't really know any other way to say that, but the number in front of your x squared not being a 1 makes them harder to deal with. I want to show you an exception to that. Looking at these, see how both the first part is a perfect square and the last part is a perfect square? If that happens, what you want to try to do is use the square root of each of those. So square root of 4x squared is 2x. So I'm going to try using a 2x and a 2x. Square root of 9 is 3. I'll put two pluses there. Now what you want to check is check your outside and inside to make sure that you get the 12x. So 6x, 6x, there's my 12x, so this is good. Now it's possible that it doesn't work. It's just a chances are likely that it does kind of thing. Okay, so what you're looking for again is that the first term is a perfect square and the last term is a perfect square. If they are, try taking the square root of each. Okay, now this time I need to have minuses in there. Okay, so let's check the outside and inside, see if it works. So negative 21x, negative 21x is a negative 42x total. That's good. That's what I want. So this is good. Now you can write it the way we wrote it here, or you could write it as 3x minus 7 squared. Either one's fine. On things where, like multiple choice, either I gave you or SAT, they probably would write it this way. Okay, last one. So perfect square, so I'm going to take the square root of each of them, making sure to check that middle number. Okay, these are both pluses. So I've got 45x, 45x. When I add those up, I get 90, which is what I want. Now, this doesn't work every time because you have to be in a specific situation. But if you're in that specific situation, it works for you pretty well. Okay, another kind of special factoring is called difference of perfect squares. Now I want you to notice we've got perfect squares here. They're both perfect squares. Square root of x squared is x. Square root of 64 is 8. If you've got this situation, what you want to go through and do is same thing. Take the square root of each of them, but you want to have 1 minus and 1 plus. Now here's the reason you want 1 minus and 1 plus. When I go through and I FOIL this together, so first, outside, inside, last, see how these right here cancel out? That's what you want to happen. And in order for that to happen, you've got to have 1 minus and 1 plus. Also, you need to have 1 minus 1 plus to get a negative right there. Okay, so here's our difference of perfect squares. Let me go ahead and put my parentheses here. So I'll have 2m, and that's a really bad m. Let's make a better m. 2m and 2m. Square root of 49 is 7. 1 minus 1 plus. Okay, our last kind of sort of special, excuse me, special kind of factoring is called the sum and difference of perfect cubes. You probably want to have these equations written down. So pause it if you need to get 2 to get these written down. On the left-hand side, I'm just telling you whether the perfect cubes is with addition or whether it's with subtraction. The right-hand side is what you're going to plug into. Okay? So looking at my first problem here, first of all, I want to verify that they're perfect cubes. So the cubed root of x to the third is x. That's going to be my a. And the cubed root of 8 is 2, because 2 times 2 times 2 is 8. That's going to be my b. Now, because this is a plus sign right here, I'm going to plug into this top equation with the plus sign. So let me write out what I'm going to plug into. And I'm going to go through and plug in all this stuff. So there's my A, here's my B. Here's my A, here's my A, here's my B, here's my B. And then simplify down if you need to. I'm just going to make that look how we normally write it. Okay, now I want you to look at this right here. This looks like something we should factor, right? It looks like we should factor it using the trinomial stuff. However, some mathematician, and you will like this mathematician, some mathematician was able to prove that when you use these formulas, this one never factors. Okay, let's do one more of these before we kind of put everything together. Okay, now I'm going to use this formula right here with the subtraction. So I just copied this down from my formulas here. Now looking at this, the cubed root of 64x to the third is 4x to the first, because 4 times 4 times 4 is 64. X times x is x to the third. And the cubed root of 125 is 5. Don't worry about the negative in terms of that. The formula will take care of that for you. And then I'm just going to plug everything in. Now, in this first pass, I just want us to plug everything in. We'll worry about simplifying in a second. Okay, and then I'm going to simplify this whole thing down. So I'll have 16x squared, remember that squared belongs to both of them, plus 20x plus 25. Now, lucky people, some guy proved that this can't be factored again, so you're done. Okay, now the last thing that I want us to do with our factoring is to just kind of put everything together. So the stuff that I have here can be factored more than one time. So we're going to factor at least twice in each of these problems. I want you to have this in your head. Start by trying to pull things out. So we talked about it, I called it finding the common factor. If you can pull stuff out, start there. Just a word of wisdom, it makes your problem simpler. You will be glad that you did. Okay, so if I start right here, I'm going to pull a 4 out of that. So I have x squared minus x minus 6. Now see how it makes my problem smaller? Now I can factor this part again. So I need something, because this is just an x to the first now, so lucky me, I don't have to do the messy, complicated kind. I need something that multiplies to 6, adds up to negative 1. So 3 and 2, subtract to make 1. I want a negative 1, so I'm going to make the 3 negative, the 2 positive. Now see how you can factor twice on this problem? you can factor twice, factor twice. Okay, here on my second one, same thing. I'm going to pull out if I can pull out. Now looking at this, I can't do my trinomial stuff, so kind of going through my different list of things I could do. I think this is difference of perfect squares. These are both perfect squares. This is difference right here. So I'm going to go through and take the square root of each of them. 1 minus 1 plus. Okay, this one kind of reminds me of the last one that we just did. So again, I can pull some stuff out. I can pull out a 5. I can also pull out an x. So I have x squared minus 9. And this again looks like difference of perfect squares. So square root of each of them, and 1 minus and 1 plus. Okay, now on my last one here, I just wanted to give you a little bit of a heads up on this. When you're factoring, it is a big pain to factor with a negative in front of your x squared. So if you've got that situation, go ahead and pull out that negative. It's like I'm pulling out a negative 1, which just means you're going to change these signs. See how I'm changing every sign? Now, if I were to go back and distribute out that negative, look at what I would end up with. 2 negatives make a positive, minus 4. Same thing I started with. All that it does is put this in a form that's going to be easier to factor, and the math powers that be call it more simple if that negative's pulled out. So you need to pull the negative out. Now I do think I can factor another time here. This is my simpler kind of factoring. I need something that multiplies to 4, so it's got to be 4 and 1 or 2 and 2, and adds up to negative 5. Now I can make that happen if I make both of these negative. Okay, I've said this several times in here. Factoring is one of the toughest things we do. It's something you really need to work hard at getting down. You can't just let me talk at you and understand it. You really have to think and focus and really work hard. So if you need to watch this multiple times, do that. We are going to practice a little bit more, but you need to make sure you get this factoring down.